Welcome to Day 7 of Daily AI Wizard, your journey to mastering AI. I'm Anastasia, your AI guide, here to make learning AI simple and fun for everyone. Today we're diving into the basics of reinforcement learning, a unique part of machine learning. I'm excited to explore this topic with you. Today we'll cover the basics of reinforcement learning. We'll define what it is, break down how it works with a detailed process, and explore key concepts like agents, environments, and rewards. We'll also look at real-world applications, challenges, and a demo to see it in action. This lesson will help you understand how machines learn through trial and error. Let's dive into this exciting topic and get started on our RL journey. Reinforcement learning is a type of machine learning where an agent learns through trial and error. The agent interacts with an environment, making decisions and taking actions. It uses rewards for good actions and penalties for bad ones to improve its behavior over time. For example, a robot might learn to walk by trying different movements and getting rewarded for steps forward. It's like training a pet with treats to encourage the right behavior. Why is it called reinforcement learning? It's reinforcement because the learning process relies on a reward system to guide the agent. Positive actions are reinforced with rewards, encouraging the agent to repeat them. Negative actions receive penalties, discouraging those behaviors. Over time, the agent learns to maximize its total rewards by choosing the best actions. This reward-based system is what makes reinforcement learning so unique. The reinforcement learning process follows three main steps, forming a cycle of learning through experience. First, the agent observes the environment to understand its current state. Then, it takes an action and receives a reward or penalty based on that action. Next, the agent updates its strategy to maximize future rewards. This cycle repeats, allowing the agent to improve over time. It's a dynamic process of learning by doing. Let's explore a key concept in reinforcement learning, the agent. The agent is the learner or decision-maker in the RL process, responsible for taking actions. It interacts with the environment by observing states and choosing actions. The agent's goal is to maximize its total rewards over time. For example, a game-playing AI, like one playing chess, acts as the agent, learning to win by earning rewards for good moves. Another key concept is the environment in reinforcement learning. The environment is the world the agent interacts with, providing the context for learning. It gives the agent states to observe and rewards based on actions taken. The environment can be simple, like a game, or complex, like the real world. It defines the rules of interaction, shaping how the agent learns and behaves over time. The third key concept is rewards in reinforcement learning. Rewards are the feedback the agent gets from the environment after taking an action. They're positive for good actions and negative for bad ones, guiding the agent's learning. For example, an agent might get +1 for winning a game and 1 for losing. The agent's ultimate goal is to maximize its cumulative rewards over time, learning the best actions to achieve this. A fundamental concept in reinforcement learning is exploration versus exploitation. Exploration means trying new actions to learn what works, even if it's risky. Exploitation involves using known actions that have previously led to rewards. Balancing exploration and exploitation is crucial for effective learning, as too much of either can limit progress. For example, an agent might try new moves in a game or repeat ones that led to wins, finding the right mix. Reinforcement learning has two main approaches, model-free and model-based. Model-free RL learns directly from experience, without predicting the environment's behavior. Model-based RL uses a model of the environment to plan actions, making it more efficient in some cases. Each approach is suited for different tasks, depending on the complexity of the environment. Let's explore both types to understand how they work in reinforcement learning. Reinforcement learning relies on algorithms, which are the rules the agent uses to learn from rewards. These algorithms are used in both model-free and model-based RL, depending on the approach. Examples include Q-learning and SARSA for model-free RL, and DQN, which uses neural networks for complex tasks. The choice of algorithm depends on the task's complexity and the environment. Let's look at a few popular algorithms to see how they work in RL. Reinforcement learning powers many real-world applications across various fields. Game-playing AI, like AlphaGo, uses RL to master games like Go, beating world champions. In robotics, RL helps robots learn tasks like picking objects through trial and error. Autonomous vehicles use RL to navigate traffic, optimizing their driving decisions. RL is a versatile tool that optimizes decision-making in industries from gaming to transportation. Reinforcement learning comes with several challenges. It often requires many trials to learn effectively, which can take a lot of time. Balancing exploration versus exploitation is tricky, as we discussed earlier. Sparse rewards, where rewards are rare, make it hard for the agent to learn what's right. Additionally, RL can be computationally expensive, requiring significant resources for complex tasks. These challenges highlight the need for careful design in RL applications. That's it for Day 7, everyone. Thank you for joining me on this AI journey. I'm Anastasia, and I hope you enjoyed learning the basics of reinforcement learning. If you found this lesson helpful, please give it a thumbs up, subscribe, and hit the bell for daily lessons. Tomorrow we'll explore an introduction to neural networks, a key topic in machine learning.